Hello everyone and welcome to this video today in our YouTube channel. In today's video we shall be looking at this question I have here on screen, which says that given that one root of the equation ax squared plus bx plus c equals to 0 is the square of reciprocal of the other, we should show that a cubed plus abc plus c cubed is equal to 0. Okay guys, please, just for a quick reminder, if you're new to our channel, please make sure you hit the subscribe button before you go, and press the bell icon such that each time we upload videos you will be the first person to be notified. And guys, please don't forget to give this video a like. Just please press the like button beneath this video, because by that way, that is your own gift to me. That is your own gift, and it's going to motivate me enough to keep producing more and more contents for you. Thank you very much for subscribing. Thank you for liking, and please don't forget to share the video out with your friends so that you can have access to good contents like this. Thank you very much. If along the solution you have any difficulty, feel free to put it in the comment section and I'm going to reply to it as soon as possible. Thank you so much, and let's dive straight into the video today. Okay, now they want us to show that a cubed plus abc plus c cubed equal to 0, given that one root of this equation is the square of reciprocal of the other. Okay, now guys, let's start with our first step. Let's assume that one of the root is beta. Okay, let's just say that one of the root is beta. You can let one of the root to be alpha, you can let it to be mu, you can let it to be lambda, you can let it to be lambda, and so on and so forth. But in this case, I've chosen beta. Okay, it's my decision. I choose beta. You could choose anything, like I said. So now guys, if one of the root is beta, what will the other root be, considering the fact that one of the root is the square of reciprocal of the other? So guys, if one of the root is beta, that therefore means that the other root must be what? Hey guys, please just pause the video and try it, then you come back later on now and view the solution. Please just pause the video and try it. Okay, I'm sure you've done that right. Great. So if one of the root is beta, that therefore means that the other must be what? Must be 1 over beta squared, because beta is what? Square, right? And it is the reciprocal, because they said it is the square of reciprocal. Square means you have the square, then reciprocal means 1 over it. Good. So now this is what you have to do. Your first step. This is your first step, guys. If you're unable to get this correctly, I don't know if you might be able to get this question correct. Okay, you could still let one of the root to be beta, and the other is 1 over square root of beta. Okay, just check that out. I think you still have the same answer. You still have the same. So you can either let one of the root to be beta and the other is 1 over beta squared, or you let one to be beta and the other is 1 over the square root of beta. Okay, because beta is the same like the square of the reciprocal of 1 over the square root of beta. Okay, yeah, good. So these two approaches can still go, but in this case we are going to dwell just with this one. We are going to use just this approach. All right, now guys, we should also know that the product of roots of beta and 1 over beta squared, that is equal to what? C over a. Right, that is equal to our c over a. Now if we take beta and we multiply by 1 over beta squared, guys, we are still going to have we have a 1 over beta squared here. We multiply that by beta, that is equal to c over a. So if we now do the normal multiplication, now this beta will cancel one of them here. We are going to have 1 over beta equal to c over a. So now if we solve for beta now by inverting both sides, we are simply going to have our beta to be now equal to a over c. Alright guys, this is the value of beta in which we have. This is one of the root. Okay, now let's now go ahead that also the sum of the roots of beta and 1 over beta squared, that has to be equal to what? Negative b on a. Great. I'm sure we are familiar with these two. We are familiar with this expression and this, right? I'm sure we are familiar with them from symmetric roots of alpha and beta, from quadratics, all that. Yeah, we are familiar with them. So guys, the sum of roots likewise of beta and 1 over beta squared, that has to be equal to negative b over a. Now that therefore implies we are going to have beta plus 1 over beta squared, which is the same like negative b over a as we have here. So guys, now in this case we are going to multiply all through by beta squared because we do not like fraction, so we multiply all through by beta squared, and by so doing guys, beta squared times beta simply gives us beta cube as we have, then the beta will cancel itself here to give us 1, then we have negative b over a into beta squared. But keep in mind guys that what is our beta? Our beta is what? A over c. So we are simply going to replace everything here by with a over c. So we are going to have a cube over c cube plus 1, which is the same like negative b over a stays. Then beta squared is, since our beta is a over c, square that gives us a squared over c squared. Good. So now once again, if we multiply all through by c cube, we are simply going to have a cube here, then plus c cube times 1 gives us c cube, which is equal to, we have the negative, we have c cube here into ab over c squared, but c squared will cancel c squared here, means we are going to be left with just 1 c here. So we are simply going to have a cube plus c cube, which is the same like, this is ab, we have it here, then we have it here, then the negative and the one of the c that were left. So this is exactly what we have. So now if we send negative abc inside, the sign here is negative, right? So if it comes inside now, the sign becomes positive. So we are simply going to have our proving out a cube plus abc plus c cube equal to 0. So thank you very much guys for watching the video, and like I said, if you had any difficulty along the line, just leave it in the comment section and I'm going to reply to it as soon as possible. Thank you for watching, and like the video please, and subscribe to our channel.